start. Ito lang. Okay, so iahabol ko lang yung scheduling of footing tie beams. So, sino dito yung may project na may tie beams? Sino sa inyo? May tie beams? Meron tie beams?
Ay, nako naman talaga, oo.
Okay. Pero sige, iahabol ko na rin. Yung scheduling kasi ng tie beams, iba yung method niya kumpara doon sa mga beams na nasa superstructure. Always remember na yung footing tie beam ninyo is part of your substructure. It is part of the foundation plan. Okay, since nasa ilalim siya, kapag nagkaroon ng earthquake, okay, it is subjected to stress reversal, kung tawagin. Stress reversal. Later on, emphasize ko to. Stress reversal. Okay? The stress reversal, actually, that is the cause of liquefaction. Okay. Pero, paano ba i-schedule muna yung footing tie beams? Let's say, paano ko? Okay? So, paano ba siya i-schedule? Di ba, normally, pag sa isang biga, ang ino-consider natin is the highest AS. Then, from the highest AS, we will determine the diameter of the rebar. Tapos, gagawin natin, titignan natin if it will fit the beam according to the specified spacing of the NCP. Pero, dito, the same pa rin. Okay? For the whole stretch ng footing tie beam, again, you will consider the highest AS. So dito, ano yung highest AS? 1183. So if I will supply diameter 16, supposing kasya na siya. Supposing, ha? Ilan diameter 16 ang kailangan ko for that 1183? Ilan? 2. 6. Kasi 5 point something, round up, it will be 6. Okay. Pagdating sa footing tie beam, kung isang bakal dyan, the highest number of bars is 6 pieces, sa lahat, 6 na rin. Okay? So, madali lang mag-schedule ng footing tie beam because you will only look for the highest AS. Then all throughout, pare-parehas na yung dami ng bakal. Top bar and bottom bar, mid span, discontinuous end, or continuous end. Okay? Later on, may nilalagay pa silang remarks. Okay? Lalagay sila ng remarks. Ano yun? Naglalagay sila no splices. Okay. Walang splice. Alam niyo ba yung splice? Ano yung splice? Nagdugtungan ng bakal. Okay? Nag-i-splice ka simply because the commercial length of the rebar cannot suffice the length of the beam. Yan nagdudugtong ka. Okay? So, naglalagay sila ng remark na no splices. Later on, may explain ko kung ano to, stress reversal, then yung no splices. Okay? But, let's jump first dito sa scheduling of stirrups. Actually, this is the second part. Scheduling of stirrups. So, in stirrups, saan sila ginagamit? They are reinforcing against shear. Okay? Kasi, pag nagkaroon ka ng shear, failure, the face of the support, okay? Kakaroon ka ng shear crack, which is at anong angle? 45 degrees. Then, andito yung stirrup, over the dead body. Okay? Magdadaanin niya yung stirrup. Then, the stirrup will resist the failure of the shear. Next. Pagdating kasi, dito sa ETABS, okay? This is your run file. This is your run file. Kung gusto nyo makita yung reinforcing ng stirrups, we go to concrete frame design, then display design information. Okay, pagdating sa ETABS, the shear reinforcement, is it an output or input? Output. Kasi dapat yung ETABS yung magsusupay sun sa'yo. So, sa design output, you choose shear reinforcing. So, may lalabas na ganyan. Okay? Now, per beam, kung mapapansin ninyo per beam, ilang set ng numbers yung makikita ninyo? Tatlo. Okay? Actually, those 3 stands for the division of the critical segments of the seismic analysis. Okay? So, ano na yun? According to the ACI kasi, the critical segment will occur at L over 3 near the supports according to ACI. So ito, L over 3, L over 3. Then, yung remaining L over 3, yan yung point where your shear is low. So therefore, this is called the balance segment. Ito mga to, yung L over 3 near the supports, that is called the critical segment. Okay, pagdating sa critical segment, your spacing is fixed at 100. Okay? So lahat ng anilyo dito, naka 100 ang spacing. Except for one, yung first stirrup. Okay? Yung first stirrup kasi, according to the NSCP, the first stirrup should be offset 50 mm from the face of the support. So yung unang anilyo mo, dapat ang layo niya from the face of the support is 50 mm. Ngayon, pagdating sa beam schedule ninyo, okay? Pagdating sa beam schedule, pagdating sa stirrups, ito yung pinaka-detaling i-provide ninyo. Everything that is in blue, kayo yung magko-compute. Ano yan? First is the diameter of the stirrup, dB. Then 1 at 50. Yung 1 at 50, ito yun. Yung unang offset. Okay? Kaya 1 at 50. Isang piraso, 50 mm from the support. Then next, NS at 100. Yung NS, that is the number of stirrups at 100 on the critical segment. Magkabilaan na yan. Okay? Then yung balance at S. Yung S is your spacing. So therefore, this is the spacing on the remaining segment, which is the balance segment. Yung balance segment niyo serves as feeders. Okay? Sa gitna. Ngayon, let's have some concrete example. Okay. Ito yung binigay kong beam, may mga number siya. So as usual, tatlong output yan sa dalawa. Tatlo. That stands for the L over 3 of the beam. Okay? So yung 2B1, which is dimension of 250 by 600. Okay? So, unang-una natin gagawin is to determine dB or the diameter of the stirrup to be sufficed. Okay. Paano ba yun? Ano-ano ba muna yung diameter of the stirrup na ginagamit natin sa site? The sizes. Start at 10, then 12, tapos kung masyado na kailangan malaki, diameter 16. Okay? Now, in computing the diameter of the stirrups, in determining the diameter of the stirrups, kailangan i-consider nyo both the critical segment and the balance segment. Okay. Yung critical segment ninyo, ilan yan? Dalawa, di ba? For every beam, dalawa sila. Okay. Sa critical segment, you only have to choose one. So, alin ang pipiliin ko? Ito yung mga values ng critical segment. Anong pipiliin ko? Yung mas malaki o mas maliit? Actually, mas malaki. Okay? You will choose the higher value. Okay. Etong mga to, I will name this as the ETABS. Okay, that's the ETABS result. Yung ETABS result, ano ba yung ibig sabihin yan? Okay, yung inalabas na values ng ETABS na yan, this is your VS over FYD. Okay? This is the VS over FYD. Familiar ba sa inyo to? Familiar sa inyo to? This is the formula used in solving the spacing of the stirrups. Eh kung ang gagawin ko, i-express ko yung S in terms of ETABS result. Paano ko i-rearrange ngayon yung equation? Diba ito, papalit ko lang dito. So therefore, magiging ano? AB over ETABS. Then, it's just simply to say, ang S ninyo or the spacing can be solved by dividing the area of the steel over the result of ETABS. Okay? So, ito na yung actual calculation. Okay, sabi at critical segment, dapat yung spacing mo should be greater than or equal to 100. Bakit 100? Kasi as stated, kailangan yung spacing mo is nasa 100 sa critical segment. Okay. Solving for the spacing. So dito sa critical segment, dalawang value. We will choose the higher, di ba? Which is 1.783. How about the AV. Paano yung AV? That is the area of steel. Okay? That's the area of steel. Oh, start at diameter 10. Okay? Ano yung AS niya? 79. O, 79 lang ba dito sa numerator? 79 lang ba? O meron pa? Bakit may times 2? Kasi in your stirrup, dalawang leg yung magre-resist ng shear force. Kaya times 2. Okay? Kasi kabilaan. Ngayon, solving for the spacing. Anong spacing pag diameter 10? Paki-solve. Ilan?
88.61.
88.61 mm. Is this greater than 100? Obviously not. So therefore, reject diameter 10. Reject diameter 10. Eh kung hindi na kaya ng diameter 10, what's next? Use diameter 12. Eh kung gagamitin mo ang diameter 12, ano lang may iba dyan? Dito, anong may iba? Yung 79. I will change that to, ano yun? 113 divided by 1.78. So yung spacing mo will become 126.75. So ito, pasok ba? Pasok. Yes. So kung pasok, use diameter 12. Pero, hindi nyo pa pwedeng i-declare yung bar diameter na 12 as the bar diameter of the stirrup. Bakit? May isa ka pang balance segment. Okay? May segment ka pa na kailangan satisfy, which is the balance segment.